Welcome to the deep dive. We take your sources, sort through all the noise, and really try to hand you the clearest insights. Today, we're tackling something really crucial for, managing sensitive info in modern tech setups. Kubernetes Secrets. Our mission is pretty straightforward. Take your sources, especially some great stuff from Kubernetes Secrets, managing sensitive data securely, and just boil it down, make it clear, make it actionable. We want to cut through the jargon, really get to the heart of what you need to know. So the big question we're wrestling with is, well, it's vital. How do your applications handle confidential data securely? Things like passwords, API keys, certificates, especially when they're running in something as complex and dynamic as Kubernetes. For years, this was a real headache, for devs, for ops teams. Think of Kubernetes Secrets like a secure digital vault, specifically for that kind of sensitive information. Today, we're going to crack open that vault for you, see what's inside, and really understand how it all works. Okay, so let's unpack this a little. At its core, right, in Kubernetes, a secret is this specific dedicated resource. It's designed just for storing and managing sensitive data. Now, it's really important to contrast this straight away with ConfigMaps. ConfigMaps handle the non-sensitive stuff.
Exactly, like general app settings or maybe environment configs that aren't secret.
Right, and that distinction is key. Secrets get extra care because they're guarding your most sensitive info.
Yeah, and it's interesting why secrets even exist and why they're so essential now. Before systems like Kubernetes, it wasn't rare to see developers, maybe accidentally, hard code credentials right into their code.
Oh yeah, I've seen that nightmare fuel,
Yeah,
like a database password in a public Git repo.
exactly. Anyone can find it. Secrets fundamentally fix this. They give you a secure, central way to decouple that sensitive data from the actual application code. It just drastically limits how much that data is exposed unnecessarily. And beyond just hiding it, they offer amazing flexibility. You can get this sensitive data into your application pods in, well, different ways. Maybe as an environment variable or mounted as a file or even used directly for authentication. And crucially, they tie right into Kubernetes role-based access control, or RBAC.
RBAC. Okay, so that's like the security guard inside Kubernetes.
Pretty much, yeah. It lets you set up very specific permissions based on roles. So only the right identities, usually service accounts, get the keys to certain secrets, certain parts of the vault, if you like. This also really helps with portability. You can use the exact same container image in dev, staging, prod, but inject different environment-specific secrets for each without ever compromising security. It keeps things consistent and secure.
That makes total sense. It's all about putting that sensitive stuff in a very controlled box. And, to really get how this works, we need to touch on a few basic Kubernetes concepts that secrets interact with all the time. We're talking about the pod, that's the smallest thing you deploy, holds your containers,
Right.
the cluster, the whole group of machines running everything, Kubectl, that's your command line tool for pretty much
Our
everything.
main interface, yeah.
Yeah. And the API server, which is like the brain, right? The control plane part that processes all these configurations, including your secrets. Understanding these gives you the context for how secrets actually operate in the bigger picture. All right, so let's pull back the curtain a bit on the mechanics. How does this secure vault actually work under the hood? How does it get the sensitive info to the apps that need it without, well, leaving it lying around?
Okay, so at a basic level, secrets store data as key value pairs. Simple enough. And this data is typically encoded using base64. Now, this is where people sometimes get tripped up.
The base 64 thing. Yeah, I've heard confusion around that. Encoded versus encrypted. Right.
Exactly. People hear encoded and think hidden or secure. But base64 is just encoding, not encryption. Its job is really just to make sure binary data or text with weird characters can be safely transmitted or stored in places that expect plain text, like YAML files. It stops things getting corrupted. Think of it like putting a document in a specific type of envelope for shipping.
Okay, so anyone can open the envelope once it arrives. It's not locked.
Precisely. It's a standardized format for transport, not a security mechanism in itself.
That's a really critical distinction. So if base 64 isn't really providing confidentiality on its own, what does Kubernetes do to make secrets actually secure beyond just that encoding?
Right, that's where the real security features kick in. While base64 is just the surface level, Kubernetes can be configured for encryption at rest.
Encryption at rest. Okay, so that means when it's being stored.
Yes, when the secret data is saved, etc., that's Kubernetes' distributed key value store, the cluster's brain, essentially, can be properly encrypted there. That adds a serious layer of security.
So even if someone somehow got access to the raw, etc. data, the secrets would still be protected.
If encryption at rest is enabled and configured correctly, yes, that's the goal. Secrets are also confined to a specific namespace scope.
Namespaces, those logical partitions within a cluster.
Exactly. This keeps data separated. Secrets in one namespace aren't visible or accessible from another unless you specifically allow it. Great for separating teams or environments. And, like we mentioned, access control via RBAC is enforced by the API server. This drastically cuts down the risk of the wrong person or the wrong process getting access to read or change sensitive data.
Gotcha. And for people who actually, write the code or configure things, what does a secret definition look like? What are the main parts in that YAML file?
Yeah, it's pretty structured. You define it declaratively in YAML. Like most things in Kubernetes, you'll have an API version, usually V1, the kind is always secret. Then you've got metadata, which includes things like its name, which has to be unique within the namespace and the namespace it belongs to.
Okay, standard stuff.
Right. Then the really important part is the data section. This holds your actual sensitive key value pairs. But remember, the values here need to be base 64 encoded.
Ah, right. So you encode them before putting them in the YAML.
Correct. And finally, there's a type field. This gives Kubernetes a hint about what the secret is for. Opaque is the default, just generic secret data. But you might have specific types like Kubernetes.io Docker config.json for private container registry credentials, or Kubernetes.io tails for TLS certificates.
Okay, so putting it all together, the real power of secrets seems to come down to those pillars you mentioned. Security, maintainability, flexibility. How do these technical bits, the encoding, the optional encryption, RBAC, namespaces, how do they really help the overall health and resilience of a system in practice?
That's exactly it. By using secrets, you're massively improving security. You stop people hard-coding sensitive stuff or accidentally logging it. That's huge.
Yeah, definitely prevents a lot of accidental leaks.
Absolutely, and it hugely boosts maintainability. Imagine having to update an API key. If it's hard-coded, you'd rebuild and redeploy your app. With a secret, you just update the secret object. Much simpler, much faster.
Less downtime, less risk in the update process itself.
Right, and it provides great flexibility. Different apps might need secrets in different ways. Environment variables, file secrets support that. And finally, it helps meet compliance needs. Many regulations require careful handling of sensitive data, and secrets provide a mechanism for that. Think about that database password example again. Stored in a secret, injected as an environment variable. Your app gets the password securely. It's never in the code, never in version control, easy to rotate. It just makes things safer and easier to manage.
That really paints a clear picture of the practical benefits. So thinking about you, the listener, working with Kubernetes, let's shift from the how it works to the where you use it. What are some really common, high-impact, real-world scenarios where secrets are basically essential?
Oh, there are quite a few classics. Database credentials is probably the most common one. Your web app pod needs a username and password for the database. Put them in a secret, inject as environment variables. Perfect fit. Keeps those creds out of the code.
Makes sense. What else?
API keys for external services. Super common. Your app talks to Stripe or Twilio or some cloud provider API. Store that API key in a secret. Maybe mount it as a file this time, inside the container to specific paths.
Why a file sometimes instead of an environment variable?
Sometimes applications are designed to read keys from files. Or maybe the key is multi-line, which can be awkward in environment variables. It just offers flexibility. Plus, updating the mounted file can sometimes be picked up without restarting the app, depending on how the app watches the file. Keeps the key secure, easy to update. Then there's container registry authentication. If you're using private registries, like Docker Hub private repos or your own internal one, you need credentials to pull those images. You create a secret of type, Kubernetes.io Docker config.json, and reference it in your pod spec. Kubernetes handles the authentication when pulling the image. No embedding creds anywhere else.
Ah, so that's how image pull secrets work. Okay.
Exactly. And finally, a big one, TLS certificates. For enabling HTTPS on your web servers, you store the TLS certificate and the private key in a secret, usually of type Kubernetes.io TLS. Then you mount these as files into your Nginx or Apache Pod or whatever web server you're using.
Right, so web server can pick them up and serve traffic over HTTPS.
Yep, keeps the private key especially well protected, but easily deployable and manageable through Kubernetes.
So how do these secrets actually, flow through the system? Can you walk us through the life cycle from defining it to it actually landing in the application container?
Sure, it's a pretty well-defined flow. First, you, the user, define the secret in a YAML file, making sure your sensitive values are base 64 encoded.
Step 1, write the YAML.
Right. Then use kubectl apply-f your-secret.yaml or something similar. That sends the definition to the API server. The API server validates the YAML checks if it's structured correctly, if the name's okay, etc. Then it stores the secret securely, and etc. And this is a point where, if you've configured it, that encryption at rest happens.
Okay, so it's safely stored. How does the pod get it?
Good question. In your pod definition, also YAML, you reference the secret in the spec. You specify how you want to use it in from or value from for environment variables or under volumes and volume mounts if you want it as files.
You tell the pod which secret to use and how.
Exactly. Then, when the pod is scheduled to run on a node, the kubelet agent running on that specific node takes over. The kubelet talks to the API server, gets the secret data, decrypting it if necessary, assuming the node has permission, and then injects it into the container just before they start. Either sets the environment variables or mounts the volume with the secret files.
So the kubelet on the node is the one doing the final delivery.
Correct. And all along the way, RBAC policies are being checked by the API server. Can this user create the secret? Can this pod service account read the secret? If you need to update a secret, you just apply an updated YAML file. Kubectl apply again. The change gets stored in, etc. Now here's a key point. Pods don't always automatically pick up the change.
Right, they might need a restart.
Often, yes. Especially for environment variables, those are set at container start. For mounted volumes, sometimes apps can detect the final change, but a restart is often the simplest way to ensure the new value is used. And finally, you can use kubectl get secrets, kubectl describe secret name, and check pod logs carefully to monitor and verify things are working as expected.
That really lays out the whole journey from creation to use. It sounds incredibly powerful and, well, pretty secure if done right. But that brings us to the really crucial part, best practices. Because having a vault is one thing, right? Knowing how to actually keep it locked tight is another. What are the absolute must-dos?
Absolutely critical. Okay, first, use descriptive names for both the secret object itself and the keys inside it. dbprod credentials is way better than sec1. Database password is better than val2. Seems obvious, but it makes a huge difference for management, especially at scale.
Good naming hygiene. Got it.
Second, and I can't stress this enough, enable encryption at rest. Seriously. Configure Kubernetes to encrypt secrets in, etc. Check your Kubernetes distributions documentation for how to do this. It has a vital layer of protection against underlying infrastructure compromise.
Okay, encrypt at rest. Non-negotiable.
Pretty much. Third, restrict access using RBAC. Be strict. Use the principle of least privilege. Only grant permissions to read or write specific secrets to the specific service accounts or users who absolutely need them. Don't give cluster admin access to everyone.
Makes sense. Lock it down.
Fourth,
Huh.
avoid overuse. Don't just stuff everything into secrets. Only put genuinely sensitive data there. Configuration that isn't secret belongs in ConfigMaps. Keep your secrets lean and focused on what truly needs protecting. Minimizes the blast radius if something does go wrong.
Right. Don't make the vault bigger than it needs to be.
Exactly. And finally, number 5, version control with extreme care. Store the secret definitions, the YAML files without the actual encoded data, maybe using placeholders in Git or your VCS, but never, ever commit the actual base 64 encoded sensitive values to your repository, especially not a public one.
So manage the structure in Git, but keep the actual secrets out. How do people manage that?
There are tools and patterns for that, things like sealed secrets, HashiCorp Vault integration, cloud providers, secret managers, basically ways to inject the real secrets securely during deployment, separate from your main codebase repo. That's maybe a topic for another deep dive.
Okay, yeah. Keep the blueprints safe, but don't leave the combination lying around. Wow, okay. This deep dive really underscores how fundamental Kubernetes secrets are. If you're building applications on Kubernetes, you really need to understand these. They're clearly the cornerstone for managing credentials, certificates, API keys securely, and they integrate so neatly with pods, with the control plane, all designed to protect that sensitive data.
Absolutely. And maybe this leads to a final thought, connecting it to the bigger picture. Think about the principles we've discussed for Kubernetes secrets. Separating sensitive data, strict access control, the importance of encryption, avoiding hard coding. How do these ideas apply more broadly? How should you approach sensitive data management in any complex distributed system you work with, even outside Kubernetes? It's always this ongoing challenge, isn't it? Balancing the convenience developers want with the robust security the system needs.
That's a great point to ponder. How do these concepts translate elsewhere? We really hope this deep dive has given you some solid understanding, maybe sparked some ideas for your own work, or even raised new questions to explore. Thanks for joining us for the deep dive.